Hello and welcome to today's stream. We are doing Algebra and Trigonometry. This is going to be 1.5 and the usual rules apply. I'm going to do the reading and then depending upon how long that takes, we're going to do the questions part, or maybe I'll break it up into two videos. The book we're working from is called Algebra and Trigonometry. It's part of the OpenStax initiative. Download it right now. It's in the video description. The book itself is free because it's part of the Creative Commons. So get yourself the book, because when I do the questions and answers, you could actually know if I'm getting it right or wrong before I do, because you could just look at the answers in the back of the book. All right, so let's get into it. All right, so we have 1.5, that's... All right, here we go. Factoring polynomials. Imagine we're trying to find the area of a lawn that we can determine how much grass seed to purchase. Now, this is relevant to me. I am a landscaper after all. The lawn is the green portion of figure 1, or on page 49. Okay, and then the area of the entire region could be found using the formula. So, so we have, let's see here. So this is going to be length times width. So A equals to length times width, right? And this is going to be here. We're going to say this is 10x. This is 6x. Okay? And then we have a couple of areas that are occupied here. This is 4 by 4. So we have to do the whole thing, and we're going to subtract out the portions, the known portions here, basically. All right. And this is going to be here, 4. Okay. We don't know the middle length, but we can kind of deduce that in a minute. But let's follow along with the book here. So we have the whole thing is going to be 10x times 6x, which is equal to 60x squared units squared. Okay. The area of the portions that do not require grass need to be subtracted from the region. The two squares are going to be 16 units squared. So this is going to be 16 units squared, 16 units squared. The other rectangular region has one side of length 10x minus 8. So how did they get 10x minus 8? So we have, this is 10x, and then we have, this is 4, and this is 4. So we're taking 10x minus 4 plus 4, which is equal to 10x minus 8. All right. And one side length of 4. So, and we know the 4 was right here. So, and again, because we're doing area, we have to multiply this out. So we're going to say 4 times length times width. This is the 10x is our width, or our length. Our width is going to be the 4, so we're going to multiply length times width. And then we're also, but technically what we're doing is, let me see here, just a second. I made a slight error here. Let me fix this. This is not established yet. 10x refers to this distance right here by 4. So that's how we're getting the 10x minus by 4, and then we're going to take out the 8s out of it. So the way we're going to do is we're going to go 10x minus 8 times 4, which is going to be 40x minus 32. All right, and then, let's see here. Right, units squared. squared. And so the whole region of the area is going to be, so the area that has to be subtracted is going to be 2 times 16, because we have this one and this one, plus 40 minus 32, and the 16 here and the 16 here are part of our grass areas that need to be done. That's what we're subtracting out, meaning that it's kind of a double negative in the sense that first we're determining the areas we will not be using, and we're taking out the 16s. Those are areas we will be using. We're trying to ultimately get to the areas we will be using. All right, so then we have 40x minus 32. Here we go. So that comes out to, of course, this is 32. These two cancel, so this is going to be 40x units squared. They just did it that way for convenience. Another way you could imagine this, let me think here. Oh, right. So let me roll along here for a second and we'll come back to that. The region that must be subtracted is 40x units squared, meaning that this right here, this 16s is areas we're going to be covered, and these, so this will be grassed, this will not, but you could also take this block and move it down, and if you did that, you get a run like this. It will be 4 times x. So because we know the height here is 4, and we know the length is 10x, so it's 4 times 10x, so we get 40x unit squares of areas that do not need grass. All right, and then let's see here. The area of the region that requires grass seed is found by subtracting 60x squared minus 40x units squared. So we have the 6x times 10x. That gives us 60x x squared minus 40x units squared. All right. And of course, then the next thing we can do is we can factor some of it out. So 20 times 3 is going to give us 60. 20 times 2 is going to give us 40. And we can pull an x out. So 20x we can factor out times 3x minus 2 units squared. Many polynomial expressions can be written in simple forms by factoring. In this section, we'll look at a variety of methods that could be used to factor the polynomial expressions. Factoring the greatest common factor of a polynomial. When we study fractions, we learn that the greatest common factor, GCF, of two numbers, let's do that. This is now. So I can write that a little better. All right, the GCF of two numbers is the largest number that divides evenly into both numbers. For instance, 4 is the greatest common factor of 16 and 20 because it is the largest number that divides evenly into 4 and into 20. By evenly, it means there's no remainder. So you take two numbers, say like 20 and 100, right? What is the greatest common factor of this? Is actually going to be 20 in this case because 20 divided by 20 is equal to 1. And 100 divided by 20 is 5, right? Let's try about 16, and how about 18? Well, the greatest common factor here is going to be 2, because that 2 divided by 9, or 2 divided by 18 is 9, and 16 divided by 2 is going to be 8. So as you can see, and of course 8 is made out of 3 2's, and 9 is made out of 2 3's. But the 2's, so the 8 is equal to 2 times 2 times 2, and 9 is equal to 3 times 3. So what happens is we can't decompose them any further without having remainders. So in that case, 2 is our greatest common factor here versus 20 was here. So I hope that makes sense. In other words, what is the largest number you could divide two numbers without either of them resulting in fractions? So we don't want any fractions. We want whole numbers coming out. All right, so now the greatest common factor of polynomials works the same way. So again, what we're pulling out here is now again, you can pull out a fraction out of a polynomial, but in that case, in this case, we're talking about greatest common factors, so think of it as whole numbers. We're pulling out a whole number. All right, so let's see here. When factoring a polynomial expression, our first step should be to check for a greatest common factor. Look for the greatest common factor of the coefficients, and then look for the greatest common factor of the variables. Okay, so coefficient is going to be, that's a coefficient, that's coefficient, right? And these are the variables. Okay, so we continue. Okay, yeah, this is a fairly short section. Okay, the greatest common factor, so yeah, you identify the greatest common factor of the coefficients, that is the numbers attached to the variables, and then you find the variables, and then you combine to find the greatest common factor of the equation. So, and we're going to start doing a bunch of these. This will make sense if it doesn't yet. Determine what the greatest common factor needs to be multiplied by to obtain each term in the expression. Write the factored expression as a product of the greatest common factor and the sum of the terms we need to multiply it by. Okay, so we're going to factor some stuff here. So the first thing we're going to do, here we go. Let's do some factoring. So our first example here is 6x to the third power, y to the third power, plus 45x squared y squared, plus 21xy. So what numbers do they all have in common? By the way, if you're not sure, break it down. 2 times 3 gives us 6. 5 times 9 is 45, which breaks down to 5 times 3 times 3. And 21 is 3 times 7, right? So looking at it, what number exists across all three of them? Oh, we got a 3, and we got a 3. So our greatest common factor of the coefficients is 3. Now what about the variables? Well, we go back to the last portion of it. It's just x and y. So we have 3 times x times y. That right there is our greatest common factor. And next we're going to go 3xy. And we are going to figure out what do we have to multiply. So like this, 3xy times what will give us 6 times like that. So, and if you look at that, you're basically what you're doing is you're taking 6x to the third power, y to the third power, and you're dividing it by 3xy. Now, I mean, we don't have to go this way. I'm just breaking it down. But to show you, most of the time you can just do it in your head because it's not complicated usually. But the 3 and the 6 gives us a 2. And the x and y drop these down to 2. So that comes out to 2x squared y squared. So the first one was going to be 2x squared y squared. The next one plus 45 So the 45 is a little tricky because remember, we pulled a 3 out of a 9. So we're going to take the 5 and we're going to multiply it by 3 to give us 15. And 15 times 3 is 45. And then we have an x and y out here, and we needed x squared and y squared. So we're going to put an x and a y in here. And for the 21, we know 3 times 7 is 21. And that's it, because the x and y are out here. Okay, so now we have factored the expression. And if you look in the book, yeah, that is the answer. And now to check your work, multiply it out. 3 times 2 is 6, and then the x squared, y squared goes up a notch by multiplying by x and y. So x third, y third, plus 15 times 3 is 45. X times x is x squared. Y times y is y squared. Plus 7 times 3 is 21. And we're adding an x and a y there, which recreates the original expression. All right, so hopefully that makes sense. Factoring is one of those things, it doesn't go away. You do it a lot, and eventually you don't even really think about it. Usually it's just a step in a series of steps that you end up having to do when you're trying to solve something else. You're trying to, for example, integrate a polynomial or something like that, and then you start trying various things that you can do with it to try to get it into a form where you can work with or something like that. But anyways, it's one of those things. It'll make sense. It's just like when we were factoring numbers before, x and y's, you know, like simplifying fractions and whatnot with just constants and no variables. It'll become second nature if it's not already. All right, so we're gonna go with try it number 1, x times b squared minus a plus 6 b squared minus a. So we want to factor this by pulling out the greatest common factor. So in this case, what you can do is notice that b squared minus a is the greatest common factor. Now, in a sense, this is already factored. Each of these is factored like this: x and then b squared minus a x plus 6b squared minus 6a. So if you wanted to expand it, that's what the equation actually looks like. But there is an even simpler factoring form we can do. We can take the b squared minus a and multiply it by, we're going to take times x plus 6, like that. And then if we were to expand it to prove our work, we're going to get x times b squared minus a plus 6 times b squared minus a. And there we have it. So as you can see, this is a simpler form of this, and both are forms of that. All right, let's check our try it work. 1.5. Let's see here. Try it answers. Okay. Section 1.5, b squared minus a plus x plus 6. And they also wrote it in parentheses. You have to do that. The parentheses are absolutely required because b squared minus a times x plus 6 is not b squared minus a times x plus b. That is not the same thing, obviously, because the a is going to multiply. In this case, the b squared will not multiply by both. So just keep that in mind. All right, so now factoring a trinomial with a leading coefficient of 1. Although we should always begin by looking for a greatest common factor, pulling out the greatest common factor is not the only way that polynomial expressions can be factored. The polynomial expression of x squared plus 5x plus 6 has a greatest common factor of 1, but it can be written as a product of two factors. So this can be broken down to x plus 2 and x plus 3. And the way it works is x times x is x squared plus 3x. 2 times x is plus 2x plus 6. So yeah, and let's see here. Right. Okay, good. So now trinomials of the form x squared plus bx plus c can be factored by finding two numbers with a product of c and the sum of b. So the product, two numbers, let's say, I don't know, like k and l, and then they're going to say the product of k and l is equal to c, and the sum, k plus l, is equal to b. So we want to know what gives us that. So when we look at it, if you were to just to kind of look at this thing, what can we do with it? So we know that k times l gives us 6. So k times l is equal to 6. And k plus l is equal to 5. All right, so I'm just thinking what else we can do here. I want to try something. Let's see. Let's redefine this quickly. K is equal to 5 minus L. And if we're going to substitute that, that's going to be L. Yeah, L times 5 minus L, which is equal to 6. I don't know if this is going to work or not, but I'm just curious. So we're going to say 5L minus L squared is equal to 6. And then, yeah, see, that's not really helping us here, which we could redefine this further as 5L L squared, negative L squared, plus 5L minus 6 is equal to 0. And then we would have to factor it again to break this out, which is actually, notice that the form that I have this is the same form here, basically. But it's a negative. So, yeah, it's just extra steps. This isn't going to help us because we would still have to solve it. Yeah, we could still get it, but I wouldn't go about it this way. The way to do it, just kind of play around with it. We'll get into it a little further here, but generally, you kind of have to take 6 and break it down. The way to find out if it can be factored, you take your number, and then this is going to be 6. Well, what is 6? 2 times 3, right? And then you're going to say, well, okay, that's a simple one. It's either going to work or it's not going to work. We're going to say if k plus l is equal, if k times l is equal to 6 and k is equal to 2 and l is equal to 3, well, k plus l is equal to what? Well, it's 2 plus 3 is equal to 5, and that happens to be the thing we want. That's great. So then we're able to recreate it. And if a small numbers, it's simple. I mean, if it was like a big number, it would just be hard. It will be very hard. This is much harder to do factoring than compared to all the other stuff with all the tricks we had and then all the various forms. Can every trinomial be factored as a product of binomials? No. Some polynomials cannot be factored. These polynomials are said to be prime. That is neat. Prime polynomials. But just keep in mind, you kind of have to play around with it and get used to it. Figuring out what can you take apart, what can you put together. It's actually great for just in general manipulating numbers is always good for you. Learning how to do that. All right, so let's next we're gonna go with a little bit more complex one. So we're gonna say with yeah, and basically what I was doing is we're gonna take the x squared plus 2x minus 15, and then we're gonna see. So basically, it's of the form x squared plus bx plus c. So we're gonna say list the factors of c. Okay, list of c. Okay, and c, and this is gonna be c is equal to negative 15. All right, well, what can we do? We can go 1 times negative 15. We can say negative 1 times 15. We can say 3 times negative 5. And negative 3 times 5. And yeah, so those are our 4 options. Now, we're going to take the sum and sum, okay, of factors. Factors. Okay, well, let's do this. This is going to be negative 14. This is going to be, now, in this case, sorry, let's get 1 plus negative 15 is equal to negative 14. That, I want to make sure that what I'm doing here makes sense. So now, instead of the multiplication, we're just putting a plus sign there, and we're solving the equation. So negative 1 plus 15 gives us 14. Okay, 3 plus negative 15 is going to be negative 12, and negative 3 plus 15 is equal to 12. Okay. So what we have here is we have our list of the additions and multiplications. So we have, make sure, is there any time? All right. Oh, and I'm sorry, I made a mistake. That makes a lot more sense. There we go. Okay. There. Okay. It's 3 minus 5 is negative 5 is negative 2, and negative 3 plus 5 is 2. So we were looking for, which one do we want? Well, we want the 2. So that means we want this form down here. So we're going to say x squared plus 2x minus 15 is equal to, we're going to say x. Now, when you factor x's like this, if it's x squared plus x, and it's just going to be x and x. And we don't know what the coefficients are, so in that case, what we know now is the forms that we need. It's in whichever place you want to put them is fine. It's negative 3 and plus 5. Or we could say x plus 5 and x minus 3. And let's multiply it out, see what we get. X times x is x squared. Then we're going to have plus 5x minus 3x minus 15. So that's going to be x squared plus 2x minus 15. And here we have x squared, again, minus 3x plus 5x minus 15. So that's going to be x squared plus 2x minus 15. Notice these two are the same. The order of the multiplication doesn't matter as long as what's contained in the parentheses remains consistent. So you can do this and you can do that. You could write whichever order you want there, but it's fine. But you cannot you cannot change the negative. So you can't make it negative 5 times positive 3. That's going to give you different results. All right, continuing on. All right. Yeah, and I just said it. Multiplication is commutative. So yeah, that's what I was getting at. Okay, let's factor x squared minus 7x plus 6. All right. So here's a trick. When you have a negative here, but a positive here, that means you're going to end up with two negatives. Because what happens is watch this, x minus a, and then we're going to say x minus b. And if you multiply them out, it's going to be x squared, and then it's going to be minus ax, minus bx first, and then minus ax, and then plus ab, because you're multiplying it. So that form right there, you're going to end up, and that's in the, so if you look at it right away, well, it's going to be 2 and 3, but really we need two negatives. Adding two negatives together, -2 plus -3 is going to be -5. Too small. How about 1 times 6, right? -1 plus -6. That gives us -7. That's what we want. So, and multiplying -1 times -6 gives us 6. So that's also what we want. So we're going to say x minus 1, x minus 6. So anytime you have a number, if our number b, if b is equal to a plus 1, or b is equal to a minus 1, in that case, the multiplication is going to end up taking this number here, c plus, it'll be c times 1, okay? Or it's going to be -c times -1, for example, or -c times 1, or c times -1. It'll be something of that form, because if you end up with one number here and then the same number, c plus 1, this is, over here is 6 plus 1 or minus 1. It's just, that's what you got to remember. It's a very simple trick to remember. Just you're going to do times 1. All right. So now, okay, and next thing we're going to do here is, okay. Oh, right. Let's check that. I just blew through that without even checking it. Yeah, x minus 6, x minus 1. But I mean, again, if I was to multiply it out and get the same result, that proves it. So it's proof. So factoring by grouping. Trinomials with leading coefficients other than 1 are slightly more complicated to factor. For these trinomials, we can factor by grouping by dividing the x term into the sum of two terms, factoring each portion of the expression separately, and then factoring out the greatest common factor of the entire expression. So we have 2x squared plus 5x plus 3. So in that case, all right. So we're going to go like this. We're going to say 2x, and then we're going to say x, like that. And so we're going to multiply it out right here. We're going to say 2x times x gives us x squared. And then we want to know what times what is going to give us that. So in this case, hang on, let me finish how they did it here. All right, so we're going to... Okay, I see. So what we do is do a slightly different step. We're going to take the equation. We're going to go 2x squared plus 2x plus 3x plus 3. But why that? Why not 1 and 4? 1 and 4. It has to do with how these things get multiplied out, but essentially the 2's and the 3's. You could think of it that way. But we'll do a lot more of those, so you'll see how that works. So we have this right now, so now we have portion of the expression to obtain. So next, what do we have here? What can we pull out here? So, well, we can pull out the x's and the 2's. So it's going to be 2x times x plus 1 plus 3 times x plus 1. Okay. And the greatest common factor, of course, this right here is our greatest common factor. X plus 1 times 2x plus 3. All right, so now we have done it. Okay, and of course, you could also write it the other way around. You can put this there, so that's fine. To factor a trinomial of the form ax squared plus bx plus c by grouping, find two numbers with a product. So we're going to say, so p is equal to AC, and then we're going to say Q, find two numbers with the product of AB and this, and yeah, that's fine. And the sum, find two numbers with the product of AB and then the sum of B. That is going to be okay, I see. Right. So it's going to be P and Q is equal to AC, and P plus Q is equal to B. That's what we got to do. All right. Anyway, let's keep doing it. All right, so we're going to do groupings again. I'm going to say 5x squared plus 7x minus 6. And what we're going to do is we have a trinomial. So let's see here. We're going to assign to the coefficients A, B, and C. So A is 5, B is 7, and C is negative 6. Okay? So we need to find first A times C is going to be 5 times negative 6. So that gives us 30. And then we want to know what two numbers give us a product. We want to get, in this case, now this next part, this is the first part. The next part is going to be here. So we've just assigned them like that, right? The next part is going to do, we're going to say P plus Q gives us, and let's see here, negative 30. And now we want to know what gives us, P plus Q gives us a product of negative 30, okay? So in that case, we are starting at the negative 30 part, and we got to break that down. So negative 30, and we're going to say factors first. We're going to say 1, negative 30, and then we're going to say negative 1, 30. We're going to say 5, negative 6, and we're going to say negative 6. By the way, if we get to the number we want, we can quit and stop earlier on, so that's fine. hang on a minute. One thing what we're looking for is, oh, right. The sum is going to be 7, what we want, not negative 30. And a sum of 7. So the numbers, this is, we want to know, right, P plus Q is equal to 7, which is our B. So that's what we got to do. We got to find 7. So we have 5 times 6, negative 30, 6 times 5. And now we're going to have, does that give us 7 yet? No, I don't think so. Let's try now some more. So then we have 3, there we go, negative 10, and we have negative 3 and 10. So all of those factor to 30, right? But which of those numbers are going to give us 7? Well, if you look at it now, and we're going to call these, this is P and this is Q. P and Q. Which P plus Q is going to give us 7? Well, it's not those, obviously. So it's going to be one of these two. So if we're going to say P plus Q, so that's, we're going to say 3 plus negative 10 is negative 7. And negative 3 plus 10 gives us 7. So that's what we want. So we're going to say negative 3 plus 10 gives us 7. All right? And now we're going to rewrite it as ax squared plus px plus qx plus c, and then we will factor it. So, and let's just write, let's just write them all down here. A is equal to 5, B is equal to negative 6, B is equal to 7. B is equal to 7, C is equal to negative 6, P is going to be negative 3, and Q is equal to 10. And for our purposes, we could assign Q to be, I mean, if I was to flip the P and Q around in their places, then they could be assigned in a different order. But fundamentally, one of them has to be negative 3, and the other one has to be 10, because they're going to add up to the same thing. So now, we're going to say 5x squared plus negative 3x plus 10x plus negative 6. And yeah, right. We don't need B for this. All right. So now let's break down them into factors. So 5 and negative 3, all we can pull out of here is going to be here. Let's take x. Let's say it's going to be x. Yep. 5x minus 3. And over here, 10 and 6, we can pull a 2 out of there. And that gives us 5x minus 3. Oh, look at that. And the problem has solved itself. So now we have 5x minus 3 times x plus 2. Beautiful. And if you want to check our work, we're going to multiply it out. So we have 5x times x. So that's going to be 5x squared. And plus 10x. Negative 3 is minus 3x minus 6. Comes out to 5x squared plus 7x minus 6. And is that what we originally learned? Yep, that's it right there. Perfect. All right, so that's the form. So we have to remember, for this kind of form, we want to know where what our numbers is, if we have A, B, and C, we want to know A times B is equal to C, and we want to know what is the factor of C is going to give us B. So we're going to say P plus Q is equal to B. And of course, we can solve B in terms of negative A, or in terms of C divided by A, if you don't know what B is. But B is a given one. It's the middle one right there. Okay. All right, let's keep rolling along here. All right, let's factor this one. 2x squared plus 9x plus 9. All right, so we have A, B, C. Let's assign them real quick. A is 2, B is 9, C is 9. And we have A times B. Is that 9 times 9? Okay. Is equal to 9 times C. So, sorry, first we have to determine, let's see here, A times C. So, right. So, A times C is equal to, so that's 2 times 9, and that's going to be 18. Okay. All right, now. And now the next part we're going to do, we're going to find out what P plus Q gives us B, and B is 9. All right. So we have 18, and then we want to know how to get that out of 9. What can we do? Well, what gives us 18? We have to factor it. So factor 18. 1 times 18 is equal to 18. Actually, we don't have to write equal. We understand that part. We have 1 and 18. We have negative 1, negative 18. And then we have 2 and 9. Negative 2, negative 9. We have 3 and 6. And negative 3 and negative 6. Okay. So, well, so that's going to be, so it's not these ones, because that's like too high. 17, and if we're going to add them together, and negative 19. Actually, sorry, that's going to be 1 plus, that's 19 and negative 19. This is going to be added together, 11 and negative 11. So we're going to say 19, negative 19, 11, negative 11. And finally, 9, comma, negative 9. So this is the one we want, which is this one right there. So we're going to say 3 plus 6 is equal to 9. So we have assigned P and Q and A, B, and C. So now we just have to write the form. And our form is AX squared plus PX plus QX plus C. Okay, so that's going to be 2x squared plus, where we assigned P to be P and then Q. So that's going to be plus 3x plus 6x plus 9. So in the first one, we're going to be able to pull out x. So that's going to be 2x plus 3. And then the second part, we're going to say we can pull out we have 3. We can pull out the 3. And then that's going to be times 2x plus 3. All right. And finally, we have x plus 3 times 2x plus 3. All right. Let's verify the work. So that's going to be 2x squared plus 3x plus 6x plus 9. And we have 2x squared plus 9x plus 9. And that is exactly what we wanted. There we go. We have proved it. All right. Next. So now we have this one, 6x squared plus x minus 1. So what's a sign? A is equal to 6, B is equal to 1, because 1 times x is equal to x. So that's 1, and then C minus 1. We want to know what is going to be A times C. So we want to know AC is equal to what? Well, it's going to be 6 times minus 1, negative 6. And now we're going to factor negative 6. So that's going to be negative 1 times 6. That's going to be 1 times negative 6. That's going to be negative 2 times 3. And that's going to be 2 times negative 3. Okay? What do we want? We want P plus Q is equal to B. P plus Q is equal to 1. All right, well, let's do our numbers real quick. So if we're adding, and if this is P plus Q, so again, I could just rewrite them, but we're just going to do the math. We're just imagining a plus between all of them, right? We're just imagining a plus right now. Okay. So let's do that. So that's going to be 5, and that's going to be negative 5, negative 1, and that's 1, negative 1. Okay, so we have it. We have it right here. So that's going to be negative 2 plus 3 is equal to 1. All right, so we have assigned our P's and Q's. So ax squared, let's do it. A. X squared plus px plus qx plus c. Okay, and here we go. All right, so right, ax squared, so that's 6x squared plus p is what? Negative 2? Negative 2x plus 3x plus negative 1. That's C. And then so we can pull out, we have the negative 6, and so we have 6 and negative 2. What can we pull out here? Well, we can pull a 2 out, and we can pull an x. So that leaves us with 3x, and that's going to be minus 1. And look at that. We also have plus 3x minus 1. So in this case, now if you're thinking, oh, what do we do from here? It's real simple. 2x plus 2x times 3x minus 1 plus 1 times 3x minus 1 is the same thing as 2x plus 1 times 3x minus 1. So the 1 times 3x minus 1 gives us the same result. Let's multiply it out. So that's going to be 6x squared. And then plus, there we go. Wait a minute. I have to correct myself here. So we have, right, 2x plus 1 times 3x minus 1. There. Okay. So now 2 times 3 is going to be 6x squared minus 2x plus 3x minus 1. That comes down to 6x squared and then plus x minus 1. Did I do that right? Yep. There we go. We get the same result. Proof. Okay, good. All right, now let's do this next part. Perfect square polynomials. By the way, a lot of these just got to do them over and over and over, and it'll become second nature. Perfect square of a trinomial can be written as a squared plus 2ab plus b squared, which is equal to a plus b squared. We were doing that last time. So yeah, and vice versa. But we've already been using this. All right. You gotta just remember that form, really. So this is a really simple one in that sense. If we have it, we have we were used to multiplying it out, but now we have to do the opposite. Factoring is breaking it down. You can think of it that way. So multiplying out is the opposite of factoring. So now what we have is this. So we want to do this. We have square root of 25x squared. And then we're going to say 20x. And then we're going to say we're going to divide that by 2. And we're going to divide that. I'm going to break them down slightly differently. First portion, we're going to go like this. The second portion, we're going to say 20x is equal to 2ab. And the third portion is going to be square rooting of the 4. So we know this is 2, and we know this is 5. And so, and that is equal to a, and that is equal to b. So what is 20x we get here? So then that is going to be here, we have 2 times 4 times, 2 times 2 times 5. That gives us 20. And then we just have to add the x. Now the x is actually from the a. It's 5x right there. So we have 5x. So that's going to be 20x. So there we go. If you wanted to break it down, we have 5x plus b squared. Sorry. B is 2 plus 2 squared. And if we expand it again, 5x plus 2, 5x plus 2 is going to be 25x squared plus 10x, 10x plus 4, 25x squared plus 20x plus 4. So just I probably made this a little complicated in my explanation. Let me try to simplify it on the try it factor. So we have 49x squared minus 14x plus 1. We'll take our formula, and then a plus b squared is equal to a squared plus 2ab plus b squared. So we know that 49x squared is equal to a squared, and we know that 1 is equal to 1 squared, is equal to b squared. So we can square root them. And then the result is going to be, we have 7x, and then we're going to say, we're going to arrange the order. We're going to say a is equal to plus or minus 7x, and b is equal to plus or minus 1. So in that case, what we need now is we'll look at our formula. We have 2ab, so 2ab is equal to negative 14x. Well, in that case, simply put, we know that divide this by 2, divide this by 2. We're going to say AB is equal to negative 7x. Well, in that case, we're going to take this negative, and we're going to take that positive. So we're going to say negative 7x times 1. All right, now let me check something real quick. Now, could it also have been negative 1? What if we went the other way? Can this also be... So right now we broke it down. I'm saying that the solution, and we're going to test this. We're going to multiply it out, and we're going to test everything. So if a plus b squared, it would be negative 7x plus 1 squared. So if we do that, we're going to multiply this out. Negative 7 plus 1, negative 7x plus 1. And multiply it out, which is 49x squared. It's going to minus 1 times 7x. It's negative 7x plus 1. And then 1 times negative 7x plus 1. 1 times 1 is 1. So 49x squared minus 14x plus 1. All right, that's exactly what we wanted. But let's take this a step further. What if the negatives were flipped? What would happen? What if it was 7x minus 1? 7x minus 1. All right, let's multiply it out. So that's going to be 49x, and it's going to be minus 7x. And it's going to be minus 7x, and it's going to be plus 1. So 49x squared minus 14x plus 1. So look at that. We got the same result. So it could be either way. Either one can be that solution. And basically, in this case, it can be a is equal to negative. So the answer we're going with, now I want to see what the book gave us, but basically we can say either it's going to be negative 7x plus 1 squared or 7x minus 1 squared. Now I want to check this, and then we'll take it a step further depending on what they say here. They're saying 7x minus 1 squared. So, yeah, this is try it number 4. All right, let's do that one more time. So they're saying it's 7x minus 1 squared, which is that one. Well, let's check it again. So negative 7x times negative 7x is 49x squared, because the negatives cancel. When you multiply negative by negative, it becomes a positive. Negative 7x times 1 gives you negative 7x. 1 times negative 7x gives you negative 7x. 1 times 1 is 1. So we get this thing. both are valid. Even though the book says the bottom one, the result is the same. And fundamentally, this comes back to the square rooting it. If you have a form like this, the way to find a, you can just square root it. But anytime you square root a to get a number, the result is going to be plus or minus. And it can be either one, because you can get like square. If you multiply something squared, like 2 squared, any number squared becomes positive automatically. There's no way negative unless you're doing imaginary numbers, which we're not. It's not in the reals set. So this is a more complete answer right here. Even though it's not in the book, I'm just giving you a more complete answer. It has to do with the nature of square rooting powers. But if you have a case like this, whenever you do anything like this, multiply it back and see what the result is. And if it's of this type and there's a negative in there, try by flipping the negative signs and see if you get the same result. And if you put them both down like that. But yeah, as you can see, I've proven that either of them would work. Anyways, let's continue. All right. Factoring a difference of squares. A difference of squares is a perfect square subtracted from a perfect square. Recall the difference of squares can be rewritten as factors containing the same terms but opposite signs. So we have so when you do these, here's how you remember it. If it's going to be like this, perfect squares perfect square is going to be like this, of this form. A plus b squared. The square is on the outside. And then for different squares, a squared plus b squared. It's on the inside. So notice it's here versus here. And a plus b squared is not equal to a squared plus b squared. That's why we have the two different formulas. Don't make that mistake. You don't carry the square on the inside and spray them out like that. You can't do that. So of this form is going to be a squared plus b squared is the same as going, actually, hold on a minute, difference squares. Let me correct that. There we go. Okay. So yeah, the difference of squares. In any case, technically what I did here, this is not the same thing. Where it's a plus b squared is not the same thing as a squared plus b squared. Don't make that mistake. But the difference squares takes this form. A plus b and a minus b. All right. And again, we're going to factor them, and then we are going to figure it out. So we have 9x squared minus 25. Well, let's check that real quick. So we're going to say a is equal to a squared is equal to 9x squared. And we're going to say b squared is equal to 25. And for now, we're going to not worry about the negative because it's the b's. We worry about the b's. The negative is added in the form. So we're just going to square root this. This is going to be plus minus 5. Square root this. And that's equal to plus minus 3x. Okay? And then now we just have to stick them in there and see what we get. Let's try it. 3x. And then we're going to say plus 5. And then it's going to be 3x minus 5. Now, in this case, the plus or minus, it's not going to be like a double negative. The negative comes in here. It's of this form. So we're making one of them be a negative and the other one be a positive. But let's multiply this out real quick. So we're going to say it's going to be 9x squared minus 15x plus 15x minus 25. Okay, so yeah, that's our result. Technically, here's what you can do. If you wanted to, well, let's play around with it, see what else we can do. Let's just stick a few other numbers in there. We're going to start changing signs and see what we get. So the 3x plus 5, 3x minus 5 is the answer. Now, if we were to say, if it was negative 5, then it would be like just 3x minus, or plus negative 5, 3x, I'm just doing something here, you'll see in a second, minus negative 5. Now we get 3x minus 5, 3x plus 5. We just swap places on them. So whether or not the second part is negative doesn't really matter. We don't have to worry about that one because either way we're going to get a negative and a positive. Now, what about the 3x? What happens if we pick a negative? Because both of these are positive, right? Well, we're going to try that. Let's see what we get. 3x negative. Then we're going to say plus 5, negative 3x minus 5. And let's do that. So that's going to be 9x squared. And then it's going to be plus 15x minus 15x. And that's going to be minus 25. So these cancel, and we are back to our form. So, again, we could have had a negative 3x there. So the solution, as I'm seeing, it's 3x plus 5, 3x minus 5, but also we could have gone with negative 3x plus 5, negative 3x minus 5. That's very interesting. So, by the rules of powers and square rooting, I would say that either of them would be, because we're getting the same result when it's expanded. So, and this is, where are we at? Yeah. So right here, if you look at the book, well, they just assumed that it's positive, and I guess then you just stick with that. Like, I don't know, like a lot of these cases, they're just going to make the assumption that it's the first one. Like, I'm like, I'm doing this from the perspective of someone that is studying math, and my pursuit is pure math. And also, I'm pursuing a double bachelor of pure math and computer science. Anyways, so for me, I start digging into the weeds for this stuff to try to understand the nature of it, because that's what pure math is. It's about the foundations of math, basically. So, like, when I see it, I'm like, the answer is not complete, but the books will always assume, at least the books that I've had to work with, they're going to assume that if you have this form, it's going to be a squared minus b squared. They're going to assume that it's going to be a plus b, a minus b, but as I've shown, negative a plus b and negative a minus b is also a valid answer because the two are the same. When you multiply them out, the negatives cancel. I don't know. I'd have to ask a teacher on that, but that's something you should bring up if you are doing this for any kind of class. This is a very interesting thing. I certainly wasn't expecting that to be going into the weeds on this. I'll tell you what. For now, like I said, just stick to doing the normal thing, but just keep in mind that anytime you have any number, which is like, let's say x squared, and x could be anything. X could also be variables, right? X can be like a whatever. Let's we don't know what x is, right? You could assign anything to x. For instance, x could be equal to a times b times c. We don't know how you want to factor them, or x can be like a negative also, negative a times b times c, and we don't know based on what we choose to assign to each of those. So now, just keep in mind, the result, the outcome, is going to be, if you square root this, it's going to be plus minus x anytime you choose to square root it. That's the rule for square rooting. So you got to be careful with those. Anyways, yeah, factoring is definitely interesting. All right. The sum of squares. This doesn't actually exist. You can't factor it. I mean, you can multiply them out, but you can't factor them. It's just, that's it. There's no expanding it. The sum of squares. You can't pull it out. Only of the difference of squares. And the reason why is because you have the middle part disappear. That's why you're able to factor it. But this is a complete form. A squared plus b squared. It's unfactorable, meaning that you can't do anything beyond just what you're looking at there. All right. So, okay, in general, stick to the formulas they have in the book. And like this idea right here is true. And but when you're factoring, just stick to the form, and you can assume that that the answer is they're asking for a positive version and not like the negative of a. Like they're asking for, this is the form they want to see and not this form. They're asking for, where did I write it here? I wrote a lot on the screen here. Here we go. Anyway, they're asking for this form and not this form. Just keep that in mind, even though the result's going to be the same. But of course, those are technically different numbers. Those a's are technically -3 and not 3 is not the same thing. But when you square them, you don't know which it was. You can't disentangle the squared number. It's both a negative and a positive square root of that number, basically. It breaks it down. So there's no way, once you square a number, it's just so smushed together, you can think of it, you don't know what it is to go back. Did you start with two negatives, or did you start with two positives? But for this level, they're not going to worry about it. Just stick to the formulas. So I'm not going to go into the weeds anymore. I want to get through this and show... Sorry, losing my voice. Still a little sick. Anyways, I'm going to try and get through this without any more coughing, or I'll have to finish it next time. Soap. We need some soap. Okay. Okay, so we can use SOAP to remember the signs when factoring the sum or difference of cubes. The first letter of each word is same, opposite, always positive. So for example, we have x to the third minus 2 to the third. Okay? And then we have x minus 2 and x squared plus 2x plus 4. The sign of the first two is the same as the sign between x. So in other words, this is kind of answering what I was getting at. Even though technically, like I was showing you, anyway, what I said still stands, but for our purposes here, we're using this right now. This is going in a slightly different direction, but you'll see how this works. So we have the sign of the first two is the same. So here and here, and this is always positive. So positive, positive. So it's going to be same, opposite, always positive. So same, opposite. So the negative is the same in the first one, and the second part is always positive. The sign of the first two is the same as the sign between this right there, yeah. And the sign of the 2x term is opposite of the sign, yeah, between that, and the sign of the last term 4 is always positive. So the sign of the 2x, so this sign is opposite of that sign. So basically, same in the first portion, opposite, always positive. Same, opposite, always positive. This is turning into a football game chart. All right, and then let's look at the factorings we have here. A cubed plus b cubed, and that's going to be a plus b, and then we have, so first one is going to be okay, so that's going to be the same. The next sign is going to be, so that's same. And this is going to be opposite. I can't even spell. There we go. That's going to be of the form AB plus B squared. And then this is going to be okay. So same, opposite, always positive. Hey, that's a much better looking chart, I think. All right. And we're going to say A cubed minus B cubed. So that's going to be A minus B. Same. And then we're going to say A squared plus AB. And plus B squared. Okay. So same, opposite, always positive. Same, opposite, always positive. All right, so that's pretty self-explanatory. All right, next we have all right, let's do one here. So we have Example, we have x to the third power plus 512. Okay, so that's going to be, let's take our form. That's going to be a cubed. We're going to assume these are cubed. Plus b cubed is equal to same, opposite, always positive. Okay? Well, we know that a is equal to x, and we want to cube root 512. Okay, so what times what times what is going to give us 512, right? All right, well, it's something base 2 for sure. So if you don't know for sure, what we can do is, well, we can start taking it apart. So let's break it down. 512 divided by 2 is 256. And then that's going to be divided by 2, and that's 128. So we want to know how many 2's. 2 to the 7th is equal to 1. Actually, I think it's 2 to the 7th is 256. I believe that's right. Actually, it is... No, I was right the first time. It is 2 to the 7th is 128, and 256 is 2 to the 8th, and 5/12 is 2 to the 9th. Okay? So then that means there's 9. So it is like this. Cube root 3, and that's 2 times 2 times 2 times 2 times 2 times 2 times 2, 2 times 2 times 2. All right, and when you have cube, you pay 3, you get 1 back. So paid 3, you get 1 back. Paid 3, you get 1 back. Paid 3, you get 1 back. Okay, so that's 8. So 8 times 8 times 8 is 512. So in other words, 512 is equal to 8 times 8 times 8. So, and that's the answer for B is going to be 8. So now we've established that. Let's move this a little bit. Okay. And B is equal to 8. So now what we're going to do is this form. X plus 8 times x squared minus x8 plus 64. All right. And that should be right. And yes, it is. So yeah, primarily it's breaking it down into cubes. The way to do it, like it depends. Like some numbers, another way you can do this. For instance, let's say it's I don't know. Let's take 512 again. Okay. Well, you can take a number. You can say what is 10 cubed, right? Oh, that's going to be 1,000. Okay. So what is 7 cubed? We're going to say 7 times 7 times 7. So that's 343. So we are going to be, our answer is going to be between 7 and 10, right? So you can just go 8 and then that's the answer. Or you would work down and be 9 and then hit 8 eventually. But that's another way of doing it, right? You could either completely factor the number and then see what you can pull out. That's a way that's always going to work. Now the other way will also always work, except it's just like some ways it's a little faster. You have to have a feel for a number to know approximately, like, I mean, what if it was root 5th, you know, like this to the 5th power, right? And then what if it was, okay, so what if it was like this? Okay, so like that. What do you do with that, right? Well, you can start doing one of two options. You can, again, multiply your numbers, or you can say, all right, well, what number can we pull out of 3125? Well, you can try 25. So we can say, for example, we can have, I'm just saying what we can pull out. If we pull it, it's 25 times 125, which is equal to 5 times 5 times 5 times 5 times 5. So the answer is going to be 5. Because you pay 5 and you get 1 back, like that. On a cube 5. So it's, you have to, get a feel for manipulating these numbers. But yeah, it comes well with time. All right. Let's do now. So we have 216 a to the third power plus b to the third power. So it's going to be, again, a plus b, a cubed plus b cubed is equal to a plus b, same, a squared, opposite ab, always positive, b squared. Okay, so, well, let's see here. All right, well, we know that b is just b, and we want to know what a is now. Well, we know that it's going to be an a, and we want to cube root 216, okay? So let's just try 4 times 4 times 4. That's 64, 5 times 5 times 5, 125, 6 times 6 times 6, 216. Okay, so I did, real quick, so I did 4 cubed is 64, 5 cubed is 125, 6 cubed is 216. So that's another way, or you can go 216 divided by 2, and that's going to be 108 divided by 2, and that's going to be 54 divided by 2, and that's going to be 27. Okay, and we know that 27 is 3 times 3 times 3. So now what we have is, because cubed, we have 2 times 2 times 2 times 3 times 3 times 3. Cube root, and then you're going to pay 3, get 1 back, pay 3, get another 1 back. So we end up with 6. So that's another way to do it. All right, and then let's just finish it out then. So it's going to be 6. So A6, well, let's write 6A. 6A is equal to A, and B is equal to B. So we're just going to write it in here. We're going to say 6A plus B times 36A squared minus 6AB plus B squared. All right? And check the answer. Yep. All right, good. And let's continue. Okay. Factoring a difference of squares. So ax to the third power minus 125. And we're going to say a to the third minus b to the third is equal to a squared. A the same. A minus b times a squared opposite to ab. Oh, I meant not 2ab, just ab. Opposite ab and then always positive, b squared. All right, so I'm gonna get the form right, and then we're just gonna say, what is the cube of 125, which is going to be 5 times 5 times 5, it's 5. Cube of 8x to the third power, and that's going to be 2 times 2 times 2 times x times x times x, and that's going to be 2x. All right, so now we're going to say a is equal to 2x and b is equal to 5. And so we have 2x minus 5, and then 2x squared is 4x squared, plus 2x times 5. We're going to just write that as 10x. And then we have plus 25. All right? Yep, and that's it. Good. All right, next we have another try it. 1000 x to the third power minus 1. So let's first get the form right. A cubed minus b cubed is equal to a minus b, same, times a squared, opposite, plus ab, always positive. Okay, what is a? Okay, so a is 1000, cubed is just, scratch 2 zeros, it's 10. And then just one of the x. Scratch the 3 down to 1, so that's going to be 10x. 10x, and b is just 1, because we can cube 1 or square root 1 or divide 1 by itself or multiply 1 by itself or 1 to the power of 1. It's all 1. So we have 10x minus 1 times 100x squared plus 10x plus 1. All right. All right, good. So far, so good. All right, now, factoring expressions with fractional or negative exponents. All right, like I said at the beginning of this video, there are ways of doing fractions in this. All right, so let's do that. All right, here we go. Expressions with fractional or negative exponents can be factored by pulling out a greatest common factor. Look for the variable or exponent that is common to each term of the expression and pull it out. That variable or exponent raised to the lowest power. These expressions follow the same factoring rules as those with integer exponents. So yeah, I'm going to show you real quick. So we have, for instance, 2x to the fourth plus 5x to the 3/4. Okay, so what can we pull out of that? Well, we can pull out, well, let's start with the smallest one. So this is our smallest one, and they both have 4s, so we can pull that out. And we both have x's, so we have x to the 4th. We can pull that out, and then that's going to leave us with a 2. Plus 5. Now, what do we get? So we're going to say 1/4 times b is equal to 3/4. Okay? So then, basically what we want to do is, we want to subtract 1/4 minus 1/4, which is to b is equal to 2/4, which is 1/2. Okay? So that means x to the 1/2. And then, yeah, we can just multiply it out. We have x times 1/4, so that's 2x and 1/4. And then we're going to say plus 5 times x. So now we're multiplying the fractions. We're going to have 5 with x 1/4 times 1/2. Right? And so that gives us 2x and 1/4 plus 5x. And then to do multiplication with your fractions, you probably remember, times 1/2. You need the same base. So then, or I mean, we could we add fractions. So not multiplying them out in this case, you have to add, whenever you are multiplying exponents, you're adding. And whenever you take an exponent to an exponent, then you multiply. But multiplying two exponents, so AB times AC is equal to AB plus C. Okay? So we're adding here. So that's going to be 2/4. You have to have the same denominator. That gives us 3/4. So that's equal to 5x to the 3/4. All right? So yeah. All right. Factoring the expression with fractional or negative exponents. Okay. So now we're going to factor 3x times x plus 2 to the negative third plus 4x plus 2 to the 2/3. All right? So then what is the lowest common factor that they have? Well, they have the x plus 2, and we want to know what is the negative third, right? So what is going to be, so the trick is to factor this out of that. And to do that, so what we're going to do here is, let's see here, say, well, let's pull this one out. So we're going to say x plus 2 to the negative third. And then afterwards, we're going to say, we're keeping the 3x. So that's from here. And then we're going to add 4. And remember what I said when we multiply with a, b times AC is equal to AB plus C. Well, the same thing holds for negatives. So if you want to know what this becomes, basically what we have is we're pulling that out. So basically 2/3 plus, let's call this y, gives us negative 1/3, right? And we're going to subtract this. I probably wrote this incorrectly. Let me do this one more time. Okay, here we go. Y minus, we're going to say 1/3 gives us 2/3, because we want to know what the y is. We've pulled this out of it. We've pulled it out. And now what we have here is the y. We're going to say that this 3x, here we go, times, 4 times x plus 2 to the y. What is the y? That's what we're trying to solve right now. And the way we're going to do this, plus 1/3 plus 1/3, y is equal to 3/3, which is equal to 1. Okay, so then all we got to do now is we're going to substitute the y with a 1. So we're going to have x plus 2 to the negative 1/3 with 3x plus 4 times x plus 2 to the first power, which is the same thing, which gives us x plus 2 to the negative 1/3 times 3x plus 4 times x plus 2. we're going to polish that up for a second here. Down here, we're going to say x plus 2 to the negative 1/3. And we're going to expand that. We're going to have 3x plus 4x plus 8, which is going to be x plus 2 to the negative 1/3 times 7x plus 8. And that is the final answer. This is a simplification of it. All right? Because this form right here is expanded, but it's not simplified yet. All right. Now we're going to factor one more here. This is try it number 8. All right, let's see if we can do this one. We have 2 5a minus 1 to the 3/4 plus 7a times 5a minus 1 to the negative 1/4. Okay, well, we want the smaller number, right? What is the smaller one? It is this one. That is definitely our smaller number, so we're pulling it out. We're going to say 5a minus 1 to the negative 1/4. Okay? And we're going to multiply that by 2. And we're going to multiply that by 2 times... Hang on a minute. Right. 5a minus 1. We're going to call it to the y for now. Plus 7a. Now the 7a, 5a minus 1 to the 1/4 times 7a gives us that portion. So hopefully that is understandable. And then this right here is that, but we've pulled this portion out of that, and that's what the y is. So we need to solve that. We don't know what that is yet, right? So we're going to say, when we've pulled it out, so we're going to say y minus 1/4 gives us 3/4. What is that? Plus 1/4 plus 1/4, which is equal to y is equal to 4/4, which is equal to 1. Okay, so now we're going to skip that step. We're just going to actually, no, we're not going to skip anything. We're just going to write the whole thing out. But I'm going to move things around a little bit so we have room to work. Okay, there we go. Okay, so now we're going to say 5a minus 1 to the negative 1/4 times 2 times 5a minus 1 to the first power plus 7a. And we just simplify that. 5a minus 1 to the negative 1/4. And then the first power, we're going to spread it out. That's just the same number. And we're going to multiply it by 2. So that's going to be 10a minus 2 plus 7a. So basically, right here, 5a minus 1 to the first power is the same thing as 5a minus 1. Okay, and 2 times 5a minus 1 to the first power is equal to 10a minus 2. Okay? Hopefully that makes sense. All right, now we are going to simplify this. 5a minus 1 to the negative 1/4. The 10a and the 7a, we're going to add that. That's going to be 17a and minus 2. All right, now let's check our work real fast here. Let's say we have 5a minus 1, 5a minus 1. All right, and 7a. Let's just check that. I want to make sure I didn't make any obvious mistakes. All right, let's see here. Pull that out. We had our 2. We pulled that out, and then we had the 7a. Good. So my only concern is that it wouldn't be subtracting the 10a or something like that. But no, well, it should be right. Let me check now. All right. Yep. All right. Everything is right. Okay. Well, of course, that's the answer right there. So, yeah, a lot. There's a lot going on, and I certainly didn't make it simpler. I kept expanding into going into all kinds of tangents. But yeah, join me next time. We are gonna do the section exercises, and yeah, we're just gonna stick by the formula. I'm not gonna try to demonstrate how there's alternative forms that we can use that give us the same answer and whatnot. I'll try to just keep it simple and just kind of go through it. But if you take the time to explore math, you learn a lot more. It gives you a much deeper understanding. And here's a trick. Okay, listen. This is something that a professor told me. Anyway, if you want to get good at math, you have to do it. You can't just watch lectures, or you can't listen to things. There's too many gaps. You will miss important things. You will not be able to recreate a formula. Don't try to memorize formulas. You should be able to recreate it. You should be able to put it together, take it apart, that sort of thing. Because, I mean, yeah, some formulas you have to memorize, but it has to be enough to where you can okay, well, if I don't know the formula, let me just take A's and B's and multiply them out and then see what happens if I spread them out and so forth. And you can recreate a formula. But yeah, you have to do the work. You have to put in the time. That's the only way to really get better at math. And this is why I'm doing these streams, is because it's for my own benefit. Now, this is a class I've passed, but there's gaps in my knowledge from not having done certain sections here, and it's having been some time. So I use this opportunity to fill in the gaps in my own understanding for the studying that I'm doing. Anyways, I hope you had fun. I know I did. See you next time.